Mineralogy, the wealth of minerals in the Eastern Sierra. Brought to you by the National Science Foundation, and the Eastern Sierra Institute for Collaborative Education.
The mining history of the Eastern Sierra is as varied and spectacular as its extraordinary mountains. From the native Paiute people mining of obsidian for tools, to prospectors in their quest for gold, to the modern-day excavation of pumice for industrial use, the mineral wealth of the Eastern Sierra has been explored and unearthed for centuries. In 1857, a prospector by the name of Cord Norst and his wife lived in a hut just south of Bridgeport. It was a hard job finding ore. He had little more than a pickaxe, shovel, and a gold pan for help. The task required lots of manual labor, and as professor of mining engineering at the University of Nevada, Reno, Dan Taylor points out, a little bit of curiosity, too.
Basically, what people knew then in terms of exploration is they would look for surface expressions of the mineral they're after, such as flakes of gold in the sediments in a creek. And then they asked, where did this come from? And they found that it was coming from an outcrop, and they started mining down the outcrop and building underground mines from that.
Norst, whose squalid homestead became known as Dogtown, became lucky and panned considerable gold from the adjacent creek. A rush of prospectors soon followed. 2 years later, the discovery of silver in a Comstock lode near Virginia City, 100 miles north, transformed this rush into a frenzy. Over the next 2 decades, mining camps and towns seemed to spring up overnight in places like Cerro Gordo, Mammoth City, Lundy, and Bodie. By 1879, gold had turned the remote mining camp of Bodie into a full-fledged boomtown with a population of 10,000 people, 2 churches, and 65 saloons. Today it's a ghost town with some 150 abandoned buildings that are preserved at Bodie State Park. So why was the region blessed with all this mineral wealth? It turns out that the earthquakes and volcanoes involved in the process of mountain building in the Eastern Sierra millions of years ago were also responsible for something else. Tommy Thompson, professor of economic geology at the University of Nevada, Reno, talks about another geologic contribution.
Certainly in the western U.S. and the 395 corridor has a lot of geothermal activity, and it's those areas where hot waters have been moving that typically also have mineral deposits that have formed or are forming at the present time.
Residual fluids from cooling magma miles below the Earth's surface force their way through cracks and fissures in the bedrock of the Sierra Nevada. These solutions are rich in minerals and precious metals, and as they rise and cool, minerals are deposited, often in the form of veins. Silica, one of the last minerals to be deposited from these fluids, forms quartz veins. Gold is often found in quartz veins as the last of these fluids crystallize. That's why the miners took gold where these quartz veins occur. As Tommy Thompson suggests, geologists believe that many of these original mines are far from tapped out.
We found most of those things that are exposed at the surface, and we need to start looking in areas that require a remote sensing technique, looking at trace element chemistry, geophysics, the rock alteration effects, and hopefully recognize something that's well above something that is found at depth.
The legacy of the mining industry, however, has been problematic because for more than a century, very little thought was given to the environmental consequences of what was left behind after all the digging was done. Taylor reflects on the past and on the future.
We're trying to figure out how to clean up the messes that other people left. The research on how do we make sure that nothing is escaping from our current mining operation is being used and applying to the abandoned mines. So there's a lot of synergy in the science and in the engineering to deal with problems like that.
Mining forever changed the Eastern Sierra, and as prospectors in a new century, science can help us understand where these resources are and how they can be developed in a responsible and innovative way. To hear and download more stories about the natural history of the 395 corridor, please visit us online at www.roadsideheritage.org.